Association versus causation. There is an association between the explanatory and response variables if the response variable changes as the explanatory variable changes. For example, there is an association between the number of firefighters who fight a fire, explanatory variable, and the amount of fire damage that occurs, which is the response variable. After all, the more firefighters that fight a fire, the larger the fire tends to be. So there tends to be more damage. However, that does not mean that an increase in the number of firefighters causes more damage. A larger fire causes more damage in the presence of more firefighters. So for figure 16, a larger fire, more firefighters, explanatory variable, more damage is the response variable. So a larger fire causes more damage in the presence of more firefighters. Now, if the change in explanatory variable causes a change in the response variable, we say there is causality. When it comes to determine causality, experiments have a huge advantage over most observational studies. Determining causality. A well-designed experiment can determine whether there is causality between the explanatory and response variables. Most observational studies cannot determine whether there is a causality between the explanatory and response variables. They can only determine whether there is an association between the two variables. So, for example, are the following studies examples of an observational study or a design experiment? Then determine if the researcher can claim causation or association. If it is an observational study, redesign the study so that it is a design experiment. For part A, researchers wanted to determine if having a television in the bedroom is linked with obesity. The researchers administered a questionnaire to 379 12-year-olds across the U.S. After analyzing the results, the researchers determined that the body mass index (BMI) of adolescents who had a television in their bedroom was significantly higher than that of adolescents who did not have a television in their bedroom. This is considered an observational study, and if it's an observational study, then this is association. So if it is an observational study, we're redesigning the study so it's a design experiment. Well, what we would do is we would have 379 12-year-olds. The treatment would be to have the TV in a room. The control would be to no TV in a room. For part B, a boss is curious to see whether caffeine helps the productivity of his employees. The boss first measures the productivity of 20 of his employees for a week. Then he makes 10 of his employees drink 2 cups of coffee every day for a week and makes the other 10 employees drink decaffeinated coffee every day for a week and measures the productivity of all 20 of his employees. He then compares the differences in productivity. So this is a design experiment which has causation. Therefore, we don't need to redesign.